So the recorder is on. All right. So the focus of the lab session today is to kind of talk about how you can script how to test your program. Now this can be useful because if you can script how you test your program, you only have to set up the test script once. And then you can be developing your program and then retest your program again and again and again with consistency. So you're not going to forget, oh, you know what, I came up with 22 test cases, but I forgot like 10 of them. Okay, because once you have these test cases, you can always use them. So what I'll do is I'm going to use your previous homework assignment, FiMax 2, as an example. Okay, so which is also a good way to kind of review how to write a program. So I'm going to do this one. In fact, I'm going to include stdint.h. In fact, I'll give you guys a hint of what you can do here. So I'm going to implement FiMax 2 using only control structures this time and not using a ternary operator. So that will give you some idea of how to get started with your current homework assignment. But obviously, this is not going to be the complete answer to what you have to do. And no, you cannot put my FiMax 2 in your program and call FiMax 2 from FiMax 3. That will make it kind of trivial as well. So your logic has to be completely contained within FiMax 3 using control structures. Because I know some of you are pretty clever. You can go like, hey, I can just call FiMax 2 twice to find the maximum of 3 variables. And the answer is yes, you can, but you may not in your homework assignment. All right, so I'm going to use exactly the same structure as your program, okay, which has max declared as a local variable, and I will use whatever is in between here to specify, okay, how does max get a useful value? So in this case, since I only have 2 variables, if x is less than y, do one thing, if not, do something else. So if x is actually less than y, y is the larger one, so obviously maximum is y. Otherwise, it's the other one, which is x. I'm done. Now we go to the main and basically just say, okay, let's declare a local variable x. X is FiMax 2. Whatever you put here is not really that important because the test script won't even run line 22. That's not even relevant. Okay, so here's my entire program, and I want to find out, okay, but how do I test this program with consistency, just so that whenever I can think of a new test case, I can add it to the script, and I will never forget it. Okay, so here's the program, and I'm going to compile the program. FiMax 2. And link the program. The warning is the usual one, which is I set a variable without actually using it. FiMax 2.0. Oops. FiMax 2.0 is here. Okay. Now the thing is, let's see how we can do it in by hand first. Okay, because a lot of what you're going to do in the script is what you can do by hand. We'll put a breakpoint in main first, and this way I don't even need to look where is the line number where main begins, because if I say B main, it means put a breakpoint on the very first statement of main, whatever it is, wherever it is. So this is really handy. And then I can just go ahead and quote-unquote run the program, which basically is just load the program and start the execution. And obviously it's going to stop on the first line. And from here, I can say print FiMax 2 4.5 is 5. We can change this one to 20, and it prints 20. And if I change the other one to 22, it's still correct. Okay. So this is how we can do it by hand. But if you do it by hand, it's okay for 2 parameters, finding the maximum of 2. But when you're dealing with 3, it gets a lot more tedious. Okay, because you have more test cases. And occasionally, when you fix one bug, you can introduce another bug. In other words, you can fix one problem, and you test the program again for that particular bug, it's resolved. But when you test it with other cases that had been working before, now they don't work anymore. Okay, that is actually possible. And it's quite common as well, when the program gets complicated. So what we want to do is not to do this by hand. Instead, we'll go ahead and create a file. So I'll just call this findmax2.gdb. The extension is not needed at all. Okay, I just use .gdb to remind myself what this file is for. It is not the source code of findmax2. It is just a script for GDB, but intended to be used with this particular program. Okay. In this file, I can just do whatever I can normally do inside GDB, which is just what I did before. Put a breakpoint in main. Okay, and then I can say print. Run first, okay, R, and then I can say print find max 2, 2, 3, and just do a few combinations here. 20, and then we can have 3 and 3, just like that. Okay. If you want to, you can even make it quit. So this way, when we run the program with GDB using a script, it will automatically get out with just the output of the program. Okay, so we'll go ahead and take a look at what this is going to do. So we say GDB, just like before. The program name is findmax2, but in addition to this, we'll now use this little caret symbol, not caret, less than symbol here. So we'll say findmax2.gdb here. What we're doing is we are actually kind of exercising the concept that we just talked about earlier. We are actually making use of findmax2.gdb as a file. But as a file, it is not just being read by VI or some other program. This time, it is serving as the input into GDB. In other words, instead of typing everything by hand inside GDB, I'm just going to say, hey, go to that file and read the content of that file, which is findmax2.gdb, as if I type it by hand. So whatever I can type by hand, I can now do it I can specify that in the .gdb file, and it's, okay, let's press enter key and find out what happens. That's the output. Now, you can see the output is kind of cryptic at this point, because this is the output of the first print statement, the second print statement, and the third print statement. Now, if you remember exactly what was being printed, then you will have no problem understanding this is actually the correct output. Right? But when you just look at the output here, you don't know whether that output is actually correct or not. So we're going to go back and refine the program a little bit, just so that it's easier to find out whether it is correct or not. So now we go back to findmax2.gdb. As it turns out, it also supports printf. Okay. So now with printf, the difference is the F stands for formatted. So that means I can now combine the output of a function with something else. So what I can do here is I can put a %d, which is a placeholder, and I think this should be 3. Let me just go back to line 3 and explain what it means. Printf is different from print because it is print formatted. Now when I say print formatted, the first thing on that line is called what we call the format. In other words, in this case, the format, quote-unquote format, consists of this part of that line. The %d is special because the %d is a space holder. Okay, it's a placeholder to basically say, oh, this particular portion should be replaced by an integer in base 10. What integer are we talking about? Whatever integer is after the double quote string. In this case, the integer is the result of findmax2 with 2 and 3 as parameters. Are we doing okay so far with this? No? Kind of? No? Okay. So let me say that again. Printf is a command in GDB. You can do it by hand as well, okay, in GDB. The first part of printf is what we call a format. A format is simply saying, okay, what am I supposed to print? Now, if you don't use the % symbol, it is just going to be printed the way it is. So that means within the double quoted string, this part is just printed the way it is specified here because there's no special % notation here. But the first thing that we have here is %d. Now, whatever you use to follow the % symbol specifies what is to be expected after the double quoted string. But in this case, because it's a D, it is expecting an integer, and it will print it out in base 10. It can also print it out in hexadecimal and some other bases, but we're only interested in base 10 at this point. So what that means is it's a placeholder in order to print whatever this thing is. Is that okay? All right. So now that we know the general format of what printf can do, we can now say, okay, let's just replicate this a few times. So instead of saying let's print between 20 and 3, we can now say the output should be 20. Oh, by the way, there's one more thing I missed. It's the \n. Otherwise, everything would be on the same line. It makes it kind of hard to read. Not impossible, just harder. So we put a 3 here, and with this one, I'm going to put a -2. Okay. So now I have a little test script that will test 4 different cases. But within each case, it will also tell me what is supposed to be the correct answer. Okay. Now you don't have to come up with all 20 test cases for your homework assignment. I'm just using 20 as a guesstimate. Okay. It can be less, can be more. It all depends on how much you think makes you comfortable. Okay. But you don't have to come up with all 20 at the same time. You can come up with 2 first, 3, and then 4, and then so on. In other words, every time I think, oh, you know what, I forgot about this test case, I can just go back to this file, add one more line, and add one more test case. Okay? All right, so let's see what this is going to do when I use GDB. So this time it's a lot more readable because the output is 3 should be 3, 20 should be 20, 3 should be 3, 3 should be 3. Now if the program has a mistake, okay, let me just make a mistake in the program, then you will see that the output is not what it is supposed to be. So this is so simple, it's hard to make a mistake. I don't know. That's pretty hard to make a mistake.
Use a double equals or something.
I'll just say let's say we put a y into max in both cases, which will make it incorrect. Okay. This is also typically what happens when people copy and paste and forget to change whatever is supposed to be changed. So we'll just go ahead and do it this way. So we'll say g++ -g-c. So now if I rerun my test script, it will say 3 should be 3, that's good. 3 should be 20, aha. You have a mistake here. So this way, you can tell. Now you can make it even more. It can tell you more stuff. In other words, you can change the GDB file. You can say instead of just that, you can say find max2. You can spell out the actual function call. Then by the time you read the output, you know which test case has failed, instead of having to go back to the script to find out which line has failed and then figure out what is the test case that made it fail. So you can make this as fancy as you want, but the whole point is you can just type, keep typing these lines here to make testing your program easier. It definitely, to me at least, it beats having to hand type all the commands every single time to retest the program. Are there any questions about this?
Go over the first part of how you created this file.
Sorry?
Can you go over the first part of how you created the file?
How I graded?
Created.
Oh, how I created? Well, this is just a text file. You can use Nano, you can use VI, you can even do it from WinSCP, and use the built-in editor of WinSCP on the other side, on the Windows side. It's just a text file, just like a .cpp file. It's just a text file. Yep.
But it's saved as .gdb?
No, it doesn't have to be.
Oh.
You can save it, with any extension. So, in this case, I'm just making it more, fancy by, spelling out, what call that I'm using, and it's giving me, what type of result here. Now, you do have to make sure that, what you think is supposed to be the answer is correct, because otherwise the script is not going to tell. It's not going to be helpful. So when I run it again, this time it tells me find max2 3 has a result of 3, and it should be 3. That's good. Find max2 2 -3 should be 2, but it's giving me a result of -3. No good. So that's what you can do. Now you can also do ternary operators. You guys remember ternary operators, right? Okay. Now with ternary operators, it can be a little bit more fun because now you can specify. These lines can tell you whether it is correct or not, like right away. So I'm going to make this a little bit more complicated by integrating the ternary operator into the message that is printing. Okay, you don't have to go this far if you don't want to, but I'm just saying that if you want to go this far, this is something that you can do. Okay. Now it seems like I'm doing quite a bit of stuff here that requires a lot of hand editing. Okay, so that means hey, it would be nice if I can define a subroutine in GDB. Okay, and the answer is yes, you can. So GDB actually supports its own type of subroutine, but I forget how to do it. So what do? I go into GDB and I say help, and let's see which one is going to be user defined. That will be the one. So within user defined, I can define something. So help define. Okay, define a new command name. Okay, definition appears on following lines. One command per line, ends with a line with just end. Okay. Command name is argument. That part is not helpful. So next thing we do is we ask Google GDB define. All right. Okay, so arguments are just arg0, arg1, and arg2. Okay, so this is really handy. I'm gonna show you exactly what I'll do with this. You don't have to fully understand it. If you want to just copy it, that's fine with me. Okay, but I'm gonna make something that's really kind of fancy. So I'll go back to findmax2.gdb, and I'll start with the definition of my own macro. So I'll say define test, okay, and end. So anything in between is going to be just commands that I want to run when I use the macro test. Okay, and the one thing I want to do is to say printf. And the format is going to be findmax2 %d is this. It should be that. So I'm leaving 4 different slots here. The 4 different slots, the first one is just going to be arg0. arg1 is the first argument. arg2 is the second one. The third one is the actual result of findmax2. So I'm going to replace it with findmax2 and then use arg1 and arg2 as the actual arguments. And then the third one, the last one, is going to be arg3, which is the expected answer. Okay. So this looks kind of obscure, but now I can, instead of using all of the individual lines, I can now just say test, and I can say test 2 and 3. The expected answer is 3 in this case. Test again, 23. This time the expected answer is 20. Test again, 3, 3, and this time the answer is supposed to be 3. In other words, I defined the macro called test. 2 goes to arg1, 3 goes to arg2, 3 goes to arg3 in this case. All right? Any questions about the way it's set up right now? No questions? Okay, let's go see whether this works or not. So GDB findmax2 from findmax2.gdb. Ah, okay, it's complaining argument 1. The user function is missing. I know exactly what it is. It doesn't like the use of parentheses. Okay. Let's try it again. Still complaining. Okay, let's see. Oh, It doesn't want even commas. Okay, fine. There we go. And it's missing argument 3 because it wants to count from argument 1. So. There we go. So this is an easy way to extend the test cases because in order to make a new test case, you just say test the first argument, the second argument to find max2, and then the expected answer. But you still have to match it by hand, right? Because you still have to say, hey, it is 3, but it's supposed to be 20. This is incorrect. So you still have to spot all of these things by hand, which is not exactly, I mean, okay, I'll put it another way. I can be lazier, okay? So I want to be saving myself some time, so I'm gonna make this even more fancy, okay? So instead of just printing this, I can now say, okay, this time I use %s, which means, the last one is a string, okay? A string is basically anything in double quotes. So this is where things get a little bit kind of interesting because now I can specify something like this. I can now say find max2 $arg0, $arg1, which are the first 2 arguments to test as a macro. And now I'm going to say, is it the same as arg2, which is the 3rd argument to test itself? And then I put all of these into parentheses, and then I put a question mark here. If it is, I say correct. If not, I say incorrect. So now, at the end of each line, it will tell me whether it's correct or not. Okay? Now, correct versus incorrect is just off by 2 characters, which makes it somewhat hard to spot. So I can use another word instead of incorrect to make it easier to find, which is just wrong. Okay? Okay. So let's go ahead and test this one. There you go. So you guys can customize and make this even more fancy if you want to. If you want to use random numbers, I think GDB has random numbers. I'm not 100% sure, but I would not use random numbers to test a program, because in that case you don't know what it is supposed to be. So I would just use known test cases, and you only really have like 6 of these plus 3 of the ones where the maximum is duplicate, and then maybe 1 that has all 3 the same. So you only really have about 10 test cases to play with. Are there any questions? So I'm going to show this on the screen again, just so that anyone who wants to do it can just freeze the screen, do a little copy the screen and then use an OCR to convert it all into text, so you don't even have to type. But is everybody kind of seeing how this can be useful when you're dealing with a more complicated program? Okay. All right, so that's it. That's all I want to show you is just how to use a script to automate the testing of your program. Any questions about this? No questions? Okay. The test script actually supports conditional statements too, and also loops if you want to. But at this point, I don't think we have to worry about that. For those of you who really want to test, like, I want the first argument to go from 1, 2, and 3, and the second one also to go from 1, 2, and 3. You can do that, except you cannot hard code in the correct answer easily that way. That's the only problem. Okay. Are there any questions? The test script is harder than the actual assignment itself. if there are no questions, the structured instruction part is over. I'm gonna upload it right away. And if you want to start working on the homework assignment now, go ahead. I'll be here until 11:50. Or if you have questions about the topics for the midterm on Wednesday, I can be here to answer those questions as well.